Hi, this is Dr. Wells for the, I believe, what will be the final lecture on deduction. Uh, we're going to do a brief bit of formal logic. It's called propositional logic, and it's based on the idea that if you have something, then there's something else. And you could say if A, then B. uh, if it rains outside, you will get wet. So if something exists, then something else exists. And so there's a whole set of logic that's built on that. And it's actually very common to uh, modern philosophers. At any rate, it's called, as I said, propositional logic, or it's a form of what's known as formal logic. It's in contrast to the informal fallacies. So the way that is normally symbolized is with the letter P and letter Q. So if P, then Q is the more or less standard symbolization of a propositional claim. If something, then something else. So what we're going to do here is talk about the logical fallout from that sort of a claim. In other words, if we have that, what follows from it. And so the basic rule is called Modus Tollens, Modustollens. And the rule says that if you negate the consequent, that you negate the antecedent. Okay, the antecedent in this case is P, that's what comes before, and the consequent is what we call Q, which is what comes after. So these phrases are identified in that way. So if you negate the consequent, which in this case would be negating Q, then you also negate the antecedent. In other words, if there are no Q's, then there cannot be any P's. Okay, so to give us hopefully a simple example of what I'm talking about is example of fire and oxygen. We'll say if fire, that would be the antecedent, then oxygen, that would be the consequent. So if we take away oxygen, the consequent, then we eliminate the fire, the antecedent. So that's an example, a simple way of understanding how that works. Let's see here. Now, let's talk about that. Modus tollens is what we've just been talking about. That is a basic fundamental rule of formal logic. Okay, so if we affirm the consequent, in other words, if we say there is oxygen, it does not follow that there must be P, fire. In other words, we can live and do with oxygen and there being no fire. Okay, so affirming the consequent is invalid. It's a formal mistake. Then if you affirm the antecedent, which is in this case saying there is fire, that would be P, then the consequent would be there is oxygen. Then if there is fire, there must be oxygen. So that is valid. So if you affirm the antecedent, you affirm the consequent. If you negate the consequent, you negate the antecedent. But if you affirm the consequent, which is there is oxygen, you do not necessarily affirm the antecedent, which is there is fire. Okay, so if you affirm the antecedent, which is, as we mentioned, fire, then there must be the consequent oxygen. So hopefully that's a good example of the kind of reasoning we're talking about. So if, let's see if I covered everything. That pretty much finishes it except for the biconditional. And the biconditional says if there is A, then there is B. And then it also says if there is B, then there is A. So in other words, it's like saying if P, then Q, if Q, then P. And so then the formal conclusion, if we negate B, we will negate A. That's modus tollens. So that holds in the biconditional. But if we negate A, we still have B, because we said not only is if A B, then we said if B A. So that in this case, a fallacy, which is affirming the antecedent, turns out to be true. Okay, so hopefully we've covered that well enough for you to handle the quiz. Make sure that when you take the quiz, you have the notes in front of you. You will need to be able to see the Aristotle square of opposition diagram. Anyway, good luck to everyone.